Now we're going to add 0.02 moles of HCl into every one of these beakers and see what happens. Now, a little confession, unfortunately, when I made this, I wrote 0.02 here, and it was too much for all these problems. So every one of these beakers in 1 through 9 is going to have strong acid at the end. But it's good practice anyway, so let's see what happens. If you add H plus into this, the first question you ask is, does it react? So if you add a strong acid and a weak acid, the answer is no. So now you're just going to go back to solution scenarios. You have a strong acid and a weak acid. We only care about the strong. So molarity equals moles over liters. What are the moles? The moles are 0.02 plus the moles of the other one, which was, if you do molarity equals moles over liters from the original. The original was 0.05 once we diluted it, remember? And then we had a total of, well, you know what? I'm sorry. Let's just go ahead and take the original anyway. We don't have to worry about that. So let's just take the original strong acid that we had, and we had to get the total moles from that. So it's going to be 0.1 molar, and it was 0.005 liters, so that's 0.0005 moles. Now you're going to add that to this, 0.00050, and the total volume is going to be 10 milliliters. So that's going to be 0.0205 moles of H plus per, oh, I'm sorry, man, really messing that one up. My bad, 0.01. So now you're going to put this over here. And when you divide that, 0.0205 divided by 0.01, you're going to get 2.05. So it's going to be a 2.05 molar H plus, and then you take the negative log of that. And you're going to find the answer to be negative 0.312. And that's going to be the pH. Okay, now we're going to add H plus into the second one. And the first question is there a reaction when you add a strong acid and a strong base? The answer is yes, stoic in moles. So we're going to do stoic in moles. So let's take that H plus that we just added. We're going to put it together with the NaOH that we had before, which we only care about the OH minus, and that's going to make water. Now we just added 0.020 moles of the H plus, ICF. Of the OH minus, what did we have before? We had let me just make a note here. This was the HCl original. Okay, so now I'm going to do the NaOH original. And that was going to be 8.1 molar equals, and again this was 5 milliliters of it, so it's 0.005 liters. And then we're going to solve for the moles, 0.00050 moles. So this is where I get my initial of the base right here. And that's where I got my original of the acid before, just for the record. Over there. Okay, so we don't care about the water right now. The running out is going to be the OH minus, so 0.0050 minus 0.0050. So when you're all done, that's a 0. And you're going to take 0.02 minus that, and you're going to get 0.0195. 0.0195. That's giving me the moles of extra H plus. So now what we want to do is you want to get the molarity. So what am I left with? I'm left with a strong acid. So I just need moles over liters. That's the same thing I was left with in the past problem, a strong acid. So strong acid, I do molarity equals moles over liters. My moles is 0.0195. My total volume is 0.010 liters. 0.0195 divided by 0.01 is going to be 1.95 molar. And then all I have to do is take the negative log of that, of 1.95, and I get a pH of negative 0.290. 0.290. So that's going to be still very acidic, but not exactly like it was in the last problem. That makes sense because we added base with this. We added an acid to a base, which makes sense that it's not quite as low as it was before. So what we're left with at the end of this is going to be simply H plus floating around in our little cup. And in this one, again, we're left with just H plus floating around in our little cup. Now we're going to add the 0.02 moles of HCl into the weak acid acetic acid. So the first question you're going to ask, is there a reaction when you do a strong acid and a weak acid? The answer is no. So now we're going to look at what we have. We have a strong acid and a weak acid. Typically, we only care about the strong. So we're going to need to know the molarity and the moles over liters for each thing. So I just added 0.020 moles of H plus, and the total volume is going to be 0.010 liters. Now I just have to find out how much did I have originally. And so I'll move this over a little bit to figure that out. Originally I had, so I'll do this over here. Originally I had 0.1 molar and I had 5 milliliters. And so when I solve this, I get 0.0005 moles of H plus originally. So I'm going to add that over here because that was still in the beaker as well. And now when you do the molarity calculation, you're going to have 0.0205 divided by 0.01, which is going to be 2.05 molar. So I have a 2.05 molar acetic acid. And now I'm just going to take the negative log of 2.05, and that's going to give me my pH, which is negative 0.312. Or I guess I should just say 0.32 for 2 sig figs. So there's my pH. Again, the strong acid was the most important thing. The weak acid added a little bit, so we just had to make sure that we got that in there. Okay, let's do the next one where we're going to add H plus into this. And now we have to ask ourselves, is there a reaction when I add a strong acid to a weak base? The answer is yes. So I do stoic in moles. All right, so let's write the stoic reaction. We're going to take this H plus that we just added. We're going to put it together with the NH3 that was already there. And we're going to make NH4 plus. So we're going to do ICF. I did O2O of this. Now I need to get my original moles of the NH3. So let's do that over here. Original moles was 0.1 molar. I had 0.005 liters. So that's going to be 0.0005 moles originally. So that goes right here, 0.0005. I don't have any of the ammonium originally. So the running out is going to be, the limiting reagent is going to be the ammonia. That's a minus, and then this is a plus. So look at what I have when I'm all done. I have 0.0195 of this, 0 of that, and I have 0.0005 of this. So I have a strong acid. So now I'm back to solution scenarios. A strong acid and a weak acid. And when that happens, I only care about the strong. So I'm going to do molarity equals moles, 0.0195 moles, over liters, 0.010 liters. So that's going to give me a 1.95 molar H plus. And then when I negative log that, I'm going to get my answer. Negative log of 1.95 is going to be 0.29, again, negative 0.29. Negative 0.29, that's giving me my final pH. So if I just want to represent what happened in the cup, all I have left is H plus, and I have a little bit of NH4 plus in here as well, but I only care about the H plus. Whereas in the previous example, I had all just H plus. I also had a little bit of acetic acid, but I only really cared about the H plus, so I didn't have to really do a calculation for the acetic acid. In number 5, we were only left with water at the end of the initial calculation. So you're simply adding 0.02 moles of HCl into water. So clearly you just have a strong acid. So what you're going to do is you're just going to do molarity equals moles over liters, 0.020 moles divided by 0.010 liters is going to be 2 molar. So 0.02 divided by 0.01 is the 2 molar, and then you're going to negative log that, and you're going to get an answer of negative log. Let's do the negative log of 2. Negative log of 2. You get negative 0.30 again. So negative log of H plus equals negative 0.30, and that's your final pH right here. So you're going to just draw a picture at the end. All you have is a little cup with H pluses floating around. Now we're going to add the, so we added H plus to this, to that one. Okay, now we're going to add to this one. So I never really drew a picture of this one. Let's do that briefly. This was a buffer. So it had, I'm just going to write HA and A minus. That was the initial. Now I'm going to throw a little H plus into this and see what happens. So the question is, will it react when you throw H plus into a buffer? Anything you throw into a buffer that's an acid or base will react. So the answer is yes. And we do stoich in moles. And I forgot to circle this was a buffer, I guess, last time, so it's a buffer. Okay, so let's do our stoich in moles. We threw in an H plus. So now we're going to write H plus over here. And we're going to put that together with the base part of the buffer, which is the A minus. And that's going to form the acid back again. So remember, we're going to do ICF for this. You need to know the moles of the H, which is 0.02. Now we need to know the original moles of the A minus. So we just take the molarity, which was 0.1, and you could see that we used 5 milliliters of that, so that equals 0.005 on the denominator, in the denominator. So it's going to be 0.0005 moles of the conjugate acid right here, conjugate base, 0.0005. Now we need to know the original acetic acid is going to be the exact same numbers, but I'm just going to write it so that we understand. Original moles of HA, the weak acetic acid, again that was 0.1 molar, and we had 5 milliliters. And so, I'm sorry, I put an extra 0 there. That should just be 2 zeros. 2 zeros. And it's not erasing, so just cross it off. Sorry about that. And you're going to solve for the top, and that's going to be the 0.0005 moles. So that goes over here. And you can see that the A minus is going to run out. So we're going to take out 0.005 of this, 0.005 of that, and make 0.0005 of this. So when we're all done, we have 0.0010 of weak acid. We have no more of this, and we have 0.015 of the strong acid. So I have a strong acid and a weak acid. So typically, you only care about the strong. So we're going to just do molarity equals moles over liters. And the moles is 0.015. The liters is 0.010. So that's going to be a 1.5 molar. And what we're going to do is take the negative log of that, and we're going to find out that that's negative 0.18. So I'm going to move this over a little bit. Oh, man. All right, I'll do it down here. That's going to be negative log of 1.5 equals negative 0.18. And that's going to be the pH. So if you want to draw a final picture of this, it's going to be a beaker or a cup that has not only H pluses, but a little bit of the weak acid. And like we said, we really only care about the strong acid when they're together. All right, what happens when we add 0.02 moles of H plus into this beaker in number 7? This beaker is a buffer. So when you add an acid into a buffer, is there a reaction? The answer will be yes. Whenever you add any acid or base into a buffer, it will react. So we do stoichiometric moles. So let's write that reaction. We take our H plus that we have here. We're going to react that with the base part of the buffer. The base part of the buffer is the NH3. And that's going to form the NH4 plus. And you're going to write your ICF. You're going to write 0.02 for this. Now, we've already figured out all these in the past, so I'm just going to write these in quickly. Okay, 0.0005, 0.0005. The limiting reagent is the ammonia, 0005. Minus 0.0005 plus 0.0005. So this is going to be 0.0010. This is going to be 0.015, and that's going to be 0. So what do I have now? Solution scenario, strong acid, weak acid. Only care about the strong. So molarity equals 0.015 over 0.010 liters. Do the math for that, of course, you get 1.5. Now you're going to negative log the H plus, and that's going to equal negative 0.18. And there's your pH. So the interesting thing is that that's what happened on the last buffer as well. The other one was an acid buffer, this is a base buffer, and they both pretty much end at the same pH, because I added just way too much HCl in these examples. So when you're all done, what do you have left in your cup? You have H plus, and you have a little bit of NH4 plus, but the amount of H's that come from there are insignificant, so we didn't even bother doing an ice problem. Okay, next we're going to look at this one. This is this actually also is a buffer, because when we were done with this problem last time, we noticed that we had HA and A minus. So we formed a buffer in the last example here when we did the initial. So this was a buffer. So again, when you have a buffer and you throw in a strong acid, is there a reaction? The answer is going to be yes, stoic in moles. So we're going to do stoic in moles with this buffer. Again, the H plus is going to react with the base part of the buffer. The base part of the buffer, I'm just going to write A minus. And it's going to form the conjugate acid, which is HA. You're going to do your ICF. This is 0.02 moles. Again, we did calculations in the past where we got the original moles. You could see them actually on the bottom of the sheet. So I'll just copy them down. The original base was this. So 0.00025 moles. The original acid is this. So 0.0005 moles. So clearly the A minus is going to run out. So we're going to subtract the 0.00025 minus 0.00025 plus 0.00025. So when this is all done, you're going to have 0.003. And this one is going to be gone. And 0.02 minus 0.00025 is going to be 0.01975. So what are we left with? A strong acid and a weak acid. And when that happens, you only care about the strong. So you're going to do, oh, this should not be, this is not a negative, by the way. This is just a regular 0.01975. So we're just going to do molarity equals moles over liters. 0.01975 moles divided by 0.010 liters. That's going to give you a concentration of 1.98 when we do rounding. 1.98 molar. So now you're going to take the negative log of that. I don't have room to write it, so I'm just going to write the answer as 1.70 is the final pH. And if you want to draw a quick picture of that, when you're all done, you're just going to have H pluses floating around and a tiny little bit of HA, which is the weak acid. Last but not least, we're going to add H plus into our final solution of number 9, which ended up being a buffer. Okay, just a quick review. It used to be a weak base to which we added a strong acid. They reacted, created a buffer, which we used the buffer shortcut. So at the end we had a buffer. Now we're going to add some H plus into the buffer, and we're going to ask ourselves, is there a reaction? And of course the answer is yes. When you add any kind of acid or base into a buffer, it will react. So then we're going to use our stoic in moles over here. I'm just going to write it out. H plus the base of the buffer is the NH3, and it's going to form the NH4 plus. So you're going to do your stoic in moles with this, ICF. I'll just write stoic in moles because was there a reaction? The answer was yes. And so just copy down 0.020 for this. I'm just going to copy down the original moles. I won't work in the millimoles. Well, why not? Let's work in millimoles just for fun. Some of you might not like the millimoles, but it's not a bad thing to do. It's a little practice. You might see it on a test sometime. So 20 millimoles for this. This one is going to be 0.50 millimoles, and the ammonia is going to be 0.25. So you could see that the 0.5 is going to run out. So minus 0.5 millimoles minus 0.5 millimoles and plus 0.5 millimoles. So this is 0, this is 0.15, 0.20 millimoles. So now what do we left? What do we have? We have a strong acid and a weak acid. So we only care about the strong. So let's do millimoles over milliliters, 0.15 over 10 milliliters. So that's going to be 0.015 molar. And then we're going to take the negative log of 0.015, and we get 1.82. 1.82 is the pH. And that'll be the final pH. So when you're all done, quick sketch, H plus, and a little bit of NH4 plus, which is insignificant for H pluses.